Okay, so in this video we are going to talk about the ideal gas law and also partial pressure. So let's start with this thing called the ideal gas law. So this is another equation and it describes a gas like at one point of time. So we used the combined gas law to calculate like the pressure of a gas when it changes volume or temperature. But this law is used to calculate quantities about a gas just at one specific time. And the equation is PV equals nRT. So you might be able to guess what a couple of these are. You know, pressure is P, V is volume. You probably don't know what N and R are yet, but T is temperature. Okay, so we're going to write those all down just so you know what they are. P is pressure, and you have to use the correct units for this equation. For the combined gas law, it doesn't matter what the units are as long as they are the same on both sides, except for temperature needs to be in Kelvin on that one. But on this one, you have to use the right units. So pressure has to be in ATM. Volume has to be in liters. N is the number of moles of whatever gas you're talking about. So obviously that's going to be in the unit of moles. So not grams. If it gives it to you in grams, you need to convert that to moles. Now R is what we call a constant. So it is a number that stays the same every time you do this equation. So it's called the ideal gas constant, and its value is 0.0821, and then it's got a bunch of units. ATM, so atmospheres times liters, divided by moles times Kelvin. So it's got all the other units that we use in this equation, and it's always going to be this number. And then T is temperature, and that has to be in Kelvin. So if they give you anything in any other units besides these, you're going to need to do some converting. So let's just do one example of calculating something with this law. So we're going to say a sample of nitrogen gas. Now nitrogen, remember, is one of the elements that is something called diatomic, so it always exists in pairs. So it's going to be N2. Has a volume of 5.56 liters at 0 degrees Celsius and 1.50 ATM pressure. How many moles of nitrogen are present in this sample? My pens are all running out here. Sorry, this takes a while to write out. Okay, so the easiest way to do this for me is to go through and label all these different numbers as far as what part of the equation they are. So, pressure, we have a pressure, it's 1.5 ATM, and that's good, it's already in atmosphere, so it's in the right unit. We have a volume, it's 5.56 liters, and that's the right unit. N is what we are looking for. We're looking for moles of nitrogen, so that's going to be our X. So this is another algebra thing. R, we already know, is 0.0821. And then our temperature is 0 degrees Celsius, but we need to convert that to Kelvin. So we need to add 273. Oops, sorry, I need to move this down. So our temperature, that's supposed to be a 7, sorry guys. So our temperature is going to be 273 Kelvin. Okay, so we've got all those different parts of the problem. Now I just need to set this up and plug everything in to my equation. So I'm going to rewrite it right here so I can see it. And then P is 1.5 ATM, V is 5.56 liters, equals my X R is 0.0821, and then that unit is ATMs times liters over mole times Kelvin, all over, or multiplied by 273 Kelvin. Okay, so to solve for x, I need to divide by everything on this side. So we'll divide by 0.0821 times 273. 0.0821, I should write my units in here, ATM, liters over mole, Kelvin, and 273 Kelvin. And now the math is a little bit tricky here, but I hope you guys can see that all of these units cancel except for moles, and moles actually ends up on the top. So if I solve this all out on a calculator, I'm actually at my computer, so I'm just going to do this on my computer. So we do 1.5 times 5.56 divided by 0.0821, and then also divided by 273. We're going to get x is equal to 0.372 moles of N2. So that's the ideal gas law. And that's how you use it. You just find all of the parts of the equation and plug them in. Okay, now let's talk about partial pressure. So when you have a mixture, you have a mixture of different gases, the total pressure of all of those gases together is equal to just adding up the pressure of the individual gases. So there's kind of an equation for this. It's P total equals P1 plus P2 plus P3 plus as many pressures as you have. So this is just saying if you have multiple gases together, just add up their pressures. So we'll just do one example of this. A mixture of gases contains 3 atmospheres of H2, 5.6 atmospheres of O2, and 10 atmospheres of N2. What is the total pressure? So this is actually really easy. All you have to do is do 3 plus 5.6 plus 10 and calculate that. So I got an actual calculator this time. So 3 plus 5.6 plus 10, so 18.6 ATM is my total pressure. Okay, so hopefully all of that made sense. And if you have any questions, just let me know.